AWS Certified Machine Learning Engineer Associate. Data preparation for machine learning, ML. Ingest and store data. Data formats and ingestion mechanisms. Apache Parquet, a columnar storage format that allows efficient querying for large-scale data analytics. It supports complex nested data structures and enables compression, making it ideal for high-performance queries. Apache ORC, similar to Parquet, but optimized for faster data reads with efficient storage. Common in big data frameworks like Apache Hadoop and Hive. Avro, a row-based storage format that supports schema evolution, allowing data to be processed and stored flexibly over time. Record I/O, commonly used in machine learning, especially with deep learning frameworks, for efficiently storing data in a serialized format. CSV/JSON, widely supported formats, useful for smaller datasets but can lack efficiency in storage and querying compared to Parquet or ORC. AWS data sources for ingestion. Amazon S3, the most common storage solution for raw, unstructured, or semi-structured data. Supports integration with various data lakes, analytics, and machine learning services. Amazon EFS provides scalable file storage accessible by multiple EC2 instances, supporting use cases where data needs to be shared across multiple applications. Amazon FSx offers high-performance file storage systems for specialized workloads. FSx for NetApp ONTAP, for example, is optimized for enterprise-level workloads. AWS streaming data sources. Amazon Kinesis, a real-time data streaming service that ingests and processes large streams of data. Used for applications such as clickstream analysis and real-time analytics. Managed service for Apache Flink enables stateful stream processing on real-time data using Apache Flink, integrated with Amazon Kinesis. Apache Kafka, an open-source platform that provides distributed streaming, widely used for building real-time data pipelines and event-driven applications. AWS storage trade-offs. S3, cost-effective for massive amounts of data but may have higher read/write latency for real-time workloads. EFS, suitable for applications that require shared storage but incurs higher costs than S3 for larger-scale datasets. FSx provides high throughput and low latency file storage for applications needing enterprise-grade file systems. Extracting data from storage. Amazon S3 with S3 transfer acceleration for faster uploads/downloads, particularly for data stored in different geographical regions. Amazon EBS, provisioned IOPS volumes for workloads requiring high-performance storage, such as databases or machine learning pipelines needing fast read/write operations. Amazon EFS, used when multiple instances or applications need simultaneous access to the same data. Amazon RDS and Amazon DynamoDB, managed relational and NoSQL databases for extracting structured data. Choosing appropriate data formats. Parquet/ORC, for large-scale analytics and columnar access patterns, where specific columns are frequently accessed. Avro, when schema evolution is necessary for data pipelines. JSON/CSV, used for simpler, smaller datasets or when working with legacy systems. Ingesting data into SageMaker. SageMaker Data Wrangler provides a visual interface to simplify the data preparation process. Allows importing data from S3, Amazon Redshift, and more. SageMaker Feature Store, a central repository for storing, updating, and serving machine learning features. Helps standardize feature engineering processes across teams. Merging data from multiple sources. Use AWS Glue for ETL, extract, transform, load, operations to integrate and transform data from various sources. Apache Spark on EMR, ideal for large-scale data processing, performing joins, aggregations, and other complex data transformations. AWS Lambda can be used for real-time data integration, running code in response to events, and pushing merged data to an S3 bucket or data store. Troubleshooting data ingestion and storage issues. Monitor S3 bucket access and performance using Amazon Cloud Watch metrics. Use AWS Glue data quality to automate data quality checks and ensure that ingested data adheres to predefined integrity constraints. SageMaker Data Wrangler can also help identify issues in data ingestion pipelines by visualizing and profiling data before it reaches the model training phase. Transform data and perform feature engineering. Data cleaning and transformation techniques. Outlier detection, techniques such as Z-score or IQR, interquartile range, to identify data points significantly deviating from the rest. Missing data imputation, common techniques include replacing missing values with the mean, median, mode, or using advanced methods like KNN imputation or model-based imputation. Deduplication, removing duplicate entries that might skew model training, especially in transactional or event-driven datasets. Feature engineering techniques. Scaling and normalization, standardizing data, mean 0, variance 1, or scaling it to a specific range, min-max normalization, to improve model performance. Feature splitting and binning, decomposing datetime fields into day/month/year or creating bins for continuous variables, making them easier for models to learn from. Log transformation, used to stabilize variance in skewed datasets, for example, transforming highly skewed financial data. Encoding techniques. One-hot encoding, suitable for categorical variables, transforming them into binary columns representing each unique category. Label encoding converts categorical data into integer values, often used in decision trees or gradient boosting models. Tokenization, splitting text into tokens, words or subwords, for NLP applications, typically followed by techniques like word embeddings, for example, word2vec. Tools to explore, visualize, and transform data. SageMaker Data Wrangler automates data cleaning, transformation, and visualization. AWS Glue Data Brew, a visual data preparation tool for cleaning and transforming data. It integrates with Glue Data Catalog for managing metadata. AWS Lambda can be used for lightweight, serverless data transformations, especially in real-time streaming use cases. Transforming data. Use AWS Glue for large-scale transformations involving complex ETL processes. Spark on EMR, efficient for distributed data processing, performing transformations like joins, filters, and aggregations across massive datasets. SageMaker Data Wrangler for seamless integration with SageMaker, enabling quick transformations without deep coding. Creating and managing features. SageMaker Feature Store. Store features for reuse across different models, ensuring consistency in training and inference workflows. Use SageMaker Data Wrangler to perform exploratory data analysis, EDA, and define features before exporting them to the feature store. Validating and labeling data. SageMaker Ground Truth helps with labeling tasks by providing workflows for creating labeled datasets, supported by human-in-the-loop labeling. Amazon Mechanical Turk offers scalable human intelligence tasks, HITs, for labeling and annotating datasets for machine learning. Ensure data integrity and prepare data for modeling. Pre-training bias metrics. Class imbalance, C, refers to the uneven distribution of classes in a dataset. For instance, in fraud detection, fraudulent transactions might represent only a small fraction of the dataset. Techniques like SMOTE, synthetic minority oversampling technique, and undersampling can balance the data. Difference in proportions of labels, DPL, a measure used to compare the representation of different classes or categories, ensuring no group is overrepresented, which could introduce bias. Strategies to address class imbalance. Oversampling, duplicating minority class instances or creating synthetic instances, for example, using SMOTE. Undersampling, reducing the majority class instances to achieve a balanced class distribution. Cost-sensitive learning, applying higher penalties to misclassifications of the minority class during training. Data security, classification, and anonymization. Encryption, use AWS Key Management Service, KMS, to encrypt data at rest in S3 or EFS, and SSL/TLS for encrypting data in transit. Anonymization and masking, techniques like hashing, tokenization, or redacting sensitive information in datasets, for example, PIF/PHI. Compliance, adhere to data regulations such as GDPR and HIPAA by implementing strict access control, encryption, and auditing via AWS Cloud. Trail. Validating data quality. Use AWS Glue Data Brew to profile, clean, and prepare data by applying built-in transformations or creating custom transformations. AWS Glue Data Quality automates the detection of anomalies or quality issues in the dataset, identifying and mitigating data bias. SageMaker Clarify detects bias in both the data and models. Clarify can help you calculate bias metrics, such as DPL, and provides guidance on reducing bias in the model. Preparing data for modeling. Ensure balanced datasets through proper data splitting, for example, stratified sampling for classification tasks, data shuffling to avoid overfitting, and data augmentation for image or text data. Set up storage for model training using Amazon EFS or Amazon FSx to provide persistent, shared access to the training data across distributed SageMaker instances. Summary for Domain 1, Data Preparation for Machine Learning. 1.1 Ingest and store data. Data formats and ingestion mechanisms. Common formats: Apache Parquet, JSON, CSV, Avro, Record IO. Ingestion from Amazon S3, Amazon EFS, Amazon FSx. Streaming data sources: Amazon Kinesis, Apache Flink, Apache Kafka. Use S3 transfer acceleration and EBS provisioned IOPS to optimize data transfer. Choose data formats based on performance and cost needs. Ingest data using SageMaker Data Wrangler and Feature Store. Handle data from multiple sources using AWS Glue or Apache Spark. Troubleshoot ingestion issues related to scalability and storage. 1.2 Transform data and perform feature engineering. Data transformation techniques. Techniques for outlier detection, missing data imputation, and deduplication. Feature engineering techniques: scaling, normalization, binning, log transformation. Encoding strategies: one-hot encoding, label encoding. Use tools like AWS Glue, AWS Glue Data Brew, Spark on EMR, and SageMaker Data Wrangler for data transformation. Create and manage features using SageMaker Feature Store. Label and validate data with SageMaker Ground Truth or Amazon Mechanical Turk. 1.3 Ensure data integrity and prepare data for modeling. Data integrity and compliance. Handle class imbalance, data bias, and strategies like resampling or synthetic data generation. Techniques for encryption, anonymization, and data masking to protect sensitive information, for example, PII/PHI. Validate data quality using AWS Glue Data Brew and AWS Glue Data Quality. Detect and mitigate bias using SageMaker Clarify. Use dataset splitting, shuffling, and augmentation to reduce prediction bias. Ensure compliance by managing sensitive data with encryption and secure storage, for example, Amazon KMS. Key takeaways. Feature engineering and data transformation improve the model's performance by optimizing input data. Bias detection and data quality assurance ensure fair and accurate model predictions, which are essential for compliance and operational success. Efficient data ingestion. Use the appropriate AWS tools and storage options based on the nature of the data and workload, for example, batch versus real-time ingestion. Efficient data ingestion, transformation, and storage are critical for building scalable ML solutions. Transformation and feature engineering. Clean and transform data using SageMaker Data Wrangler, Glue, and Spark for better model performance. Effective feature engineering is key to building accurate machine learning models. Data integrity and compliance. Ensure data security with encryption, compliance adherence, for example, GDPR, HIPAA, and bias mitigation techniques to avoid ethical and operational risks. ML model development. Choose a modeling approach. Capabilities and appropriate uses of ML algorithms. Classification algorithms for binary or multi-class problems. Examples: logistic regression, useful for binary classification with interpretable results. Support vector machines, SVM, effective for small datasets with clear margins of separation between classes. Decision trees and random forests, easy to interpret, useful for both classification and regression tasks. XGBoost, gradient boosting based method, highly effective for structured/tabular data, particularly in Kaggle competitions. Regression algorithms, for predicting continuous variables. Examples: linear regression, suitable for simple, linear relationships. Rich/lasso regression, used for reducing model complexity and avoiding overfitting with regularization. XGBoost, also used for regression tasks in addition to classification. Clustering algorithms. K-means clustering, groups data into a predefined number of clusters, good for unsupervised learning. DSCAN, density-based spatial clustering, works well for datasets with noise and varying density. Dimensionality reduction algorithms. Principal component analysis, PCA, reduces dataset dimensions while retaining most of the variance. TSNE, T-distributed stochastic neighbor embedding, useful for visualizing high-dimensional data. Time series forecasting. ARIMA, autoregressive integrated moving average, traditional method for time series forecasting. DeepR in Amazon Sagemaker, designed specifically for time series data using deep learning techniques. How to use AWS AI services. Amazon Translate, Amazon Transcribe, and Amazon Recognition solve common business needs like language translation, speech to text, and image analysis. Amazon Bedrock supports fine-tuning of large foundational models like GPT for generative tasks such as chatbots or text summarization. Model interpretability in selection. Interpretable models, decision trees, logistic regression provide transparency, important in regulated industries, for example, finance. Black box models, neural networks, XGBoost offer higher performance but are less interpretable. Sagemaker built-in algorithms. Blazing text, for text classification and word embeddings. Linear learner, general-purpose linear regression and classification. K-means, unsupervised learning for clustering. Factorization machines, for high-dimensional sparse datasets, commonly used in recommendation systems. Assessing data and problem complexity. Evaluate dataset size and type, structured versus unstructured data, categorical versus continuous variables. Problem type, classification, regression, clustering, or recommendation. Selecting the right algorithm. Classification problems, logistic regression, SVM, random forest. Time series, DeepR for time series data, ARIMA for simpler forecasting. Clustering, K-means or DSCAN based on the data's noise and density. Choosing based on cost. For large-scale models like GPT or T5, use Amazon Bedrock for easier deployment and customization without managing infrastructure. For simpler tasks or smaller datasets, use Sagemaker built-in algorithms for optimized cost and performance. Choosing AI services, use pre-built AI services like Amazon Recognition or Amazon Comprehend when model training is unnecessary. Train and refine models. Elements in the training process. Epochs, number of complete passes through the training dataset. Batch size, number of training examples used to update the model weights in one iteration. Learning rate, controls how much to change the model in response to the estimated error at each iteration. Methods to reduce training time. Early stopping, halts training when performance stops improving on a validation set, preventing overfitting and saving time. Distributed training, use multiple machines to train large models faster. Sagemaker supports data parallel and model parallel approaches. Multi-GPU training. SageMaker allows scaling training jobs across multiple GPUs for faster convergence. Factors that influence model size. Number of parameters. Larger models with more layers in neural networks or trees in decision trees tend to be more complex and require more memory. Input features. More input features increase model size and complexity. Performance optimization. Regularization, L1, lasso, and L2, ridge, penalties reduce overfitting by constraining model weights. Dropout, randomly drops neurons during training to prevent overfitting in neural networks. Ensembling methods, boosting, for example, XGBoost, or bagging, for example, random forest, to improve performance by combining multiple models. Hyperparameter tuning. Random search, randomly samples hyperparameters, simpler and faster. Bayesian optimization, more efficient, searches intelligently by using past evaluation results to guide the selection of the next set of hyperparameters to test. Grid search, exhaustively tests all combinations of hyperparameters, often computationally expensive. SageMaker script mode and frameworks. TensorFlow and PyTorch build custom training scripts with full control over the model architecture and training loop. XGBoost and scikit-learn use these libraries directly in SageMaker for common ML tasks like classification and regression. Using SageMaker built-in algorithms. Linear learner for regression and binary/multi-class classification problems. XGBoost, preferred for tabular data and problems requiring high accuracy and scalability. Hyperparameter tuning with SageMaker AMT. Set up automatic tuning jobs to find the best hyperparameters based on performance metrics, for example, AUC, F1 score. Preventing overfitting/underfitting. Overfitting, use regularization, L1, L2, dropout, or early stopping. Underfitting, increase model complexity, for example, more layers or trees, or reduce regularization. Model ensembling. Bagging, combine multiple weak learners to form a strong learner. Example, random forests. Boosting, sequentially trains models to correct errors made by previous models. Example, XGBoost. Integrating pre-trained models into SageMaker. Fine-tune models using SageMaker Jumpstart or pre-trained models from Amazon Bedrock with your own datasets. Managing model versions with SageMaker Model Registry. Track and manage different versions of models in production. This enables reproducibility, auditing, and rollback in case of performance degradation. Analyze model performance. Model evaluation metrics. Accuracy, proportion of correct predictions, can be misleading for imbalanced datasets. Precision and recall. Precision, fraction of relevant instances among the retrieved instances. Recall, fraction of relevant instances that have been retrieved. F1 score, harmonic mean of precision and recall. Useful when precision and recall are equally important. ROC curve, receiver operating characteristic, plots true positive rate, TPR, versus false positive rate, FPR. AUC ROC gives a measure of model performance across different thresholds. Root mean square error, RMSE, measures the average magnitude of errors in regression problems, creating performance baselines. Initial model metrics use a simple model, for example, logistic regression, as a performance baseline before optimizing. Benchmarking new models, evaluate new models against the baseline to measure improvement. Identifying overfitting and underfitting. Overfitting, model performs well on the training data but poorly on unseen test data. Mitigated with regularization or pruning. Underfitting, model performs poorly on both training and test data, indicating it hasn't captured the underlying patterns. SageMaker Clarify for bias detection. Analyze models for bias in feature importance and predictions. Detects potential bias in ML models and provides metrics for mitigation. Model convergence issues. Occurs when the model's error plateaus and does not improve further. Use techniques like changing learning rates, increasing epochs, or switching optimizers, for example, Adam, Mulsprop. Selecting and interpreting evaluation metrics. Binary classification, use F1 score, precision/recall, and AUC ROC to evaluate performance. Regression problems, use RMSE or mean absolute error to evaluate the performance of regression models. Assessing trade-offs between performance, training time, and cost. Performance, choose metrics based on business goals, for example, high precision in fraud detection to avoid false positives. Training time, ensure the model doesn't take too long to train, especially in iterative tuning or retraining pipelines. Techniques like distributed training or reducing epochs can help. Cost, choose resources wisely, for example, using spot instances for training or SageMaker savings plans. Larger models may increase inference costs due to longer processing times and higher infrastructure requirements. Performing reproducible experiments using AWS services. Use SageMaker experiments to track and compare different versions of models, hyperparameters, and datasets. This helps in auditing and debugging models later. Comparing shadow variant to production variant. A/B testing, deploy a model in a shadow mode without affecting production to compare its performance against the production model before full deployment. Canary deployment, gradually shift traffic from the old model to the new one to monitor performance in real time and avoid disruptions. SageMaker Model Debugger. Detect and debug issues like vanishing gradients, exploding gradients, or poor convergence by monitoring training metrics, for example, loss, accuracy, in real time. This helps identify if the model is not learning properly during training. SageMaker Clarify for model interpretability. Feature attribution, SageMaker Clarify provides sharp values to explain which features contribute most to a particular prediction, helping ensure transparency in the decision-making process. Bias detection evaluates whether the model treats all groups fairly by analyzing the predicted outcomes for different demographics. Summary for Domain 2, ML model development. Choosing a modeling approach. Understand the business problem and match it to appropriate machine learning algorithms, classification, regression, clustering. Use pre-built AWS AI services, for example, recognition, translate, when custom ML models aren't needed. Consider model interpretability, especially in industries where explaining predictions is crucial. Training and refining models. Understand the various elements in the training process, epochs, learning rate, batch size. Use hyperparameter tuning strategies, random search, Bayesian optimization, and SageMaker AMT to automate optimization. Reduce training time with distributed training, early stopping, and multi-GPU setups. Regularly evaluate model performance to avoid overfitting or underfitting. Analyzing model performance. Use appropriate evaluation metrics, for example, F1 score for classification, RMSE for regression, and create performance baselines. Utilize tools like SageMaker Clarify for bias detection and model explainability, and SageMaker Model Debugger for real-time monitoring of training performance. Implement A/B testing or shadow deployments to test new models before full-scale deployment. Deployment and orchestration of ML workflows. Select deployment infrastructure based on existing architecture and requirements. Deployment best practices. Versioning, maintain different versions of the model to track changes and allow rollbacks. Use SageMaker Model Registry to store, version, and deploy models in an organized manner. Rollback strategies. If a new model deployment negatively affects performance, use version control in SageMaker to quickly roll back to a previous version. Canary and blue/green deployments reduce risk during rollouts. AWS Deployment Services. Amazon SageMaker Endpoints. Real-time endpoints, for low-latency inference in production, where the model serves predictions as requests are received. Asynchronous endpoints, for large payloads or long-running inference jobs that don't require immediate responses. Batch transform, for batch inference, processing multiple records in one go, suitable when real-time predictions are not required. Amazon Elastic Kubernetes Service, EKS, and Amazon Elastic Container Service, ECS. Use for hosting models in containers where you want fine-grained control over deployment strategies, auto-scaling, and orchestration. EKS/ECS enables multi-container deployments, where multiple models can run on the same infrastructure, or a model can be split into multiple containers for efficiency. Lambda inference, serverless option for low-cost, scalable, and on-demand inference without managing underlying infrastructure. Serving models in real-time and batch. Real-time inference, use SageMaker real-time endpoints for tasks like fraud detection or recommendation systems where quick responses are required. Batch inference, for use cases where predictions are generated in bulk, like generating recommendations or processing user behavior overnight. SageMaker Batch Transform is ideal for this scenario. Provisioning compute resources. CPU versus GPU, use GPU instances, for example, P3, G4DN, for deep learning models requiring high computation power, especially for models like BERT or GPT-3. Use CPU instances, for example, C5, A5, for less computationally intensive models. Auto-scaling, configure auto-scaling based on traffic. SageMaker endpoints support auto-scaling, which adjusts the number of instances in response to demand. This minimizes cost during low traffic periods while ensuring high availability during traffic spikes. Endpoint requirements for model deployment. Serverless endpoints, lower cost option where traffic is unpredictable, allowing on-demand scaling without provisioning dedicated instances. Multi-model endpoints, hosts multiple models behind a single endpoint, improving cost efficiency by sharing resources. Edge inference, use SageMaker Neo for deploying models to edge devices, optimizing model performance for resource-constrained environments like IoT devices. Evaluating performance, cost, and latency trade-offs. Latency, use real-time endpoints for low-latency inference, batch inference for non-real-time requirements, and asynchronous endpoints for long-running jobs. Cost optimization, use serverless endpoints or multi-model endpoints to minimize idle compute costs, and leverage SageMaker savings plans for further cost optimization. Performance, scale infrastructure based on performance needs. Use GPU instances for deep learning models and CPU instances for traditional machine learning models. Choosing deployment orchestrators. SageMaker Pipelines orchestrates end-to-end ML workflows, including model training, tuning, and deployment. Apache Airflow on Amazon Moa, used for complex orchestration tasks beyond model training, such as integrating with multiple AWS services or orchestrating data pre-processing pipelines. AWS Step Functions manages long-running workflows, allowing you to build, monitor, and orchestrate the execution of your machine learning workflows. Selecting the correct deployment target. SageMaker endpoints, best for hosting models for real-time and batch inference. ECS or EKS, used for containerized model deployments when you need fine-grained control over scaling and infrastructure. Lambda, ideal for low latency, event-driven inference with low infrastructure management. Amazon API Gateway plus Lambda, for exposing your model as a REST API without managing servers. Model deployment strategies. Real-time deployment, set up SageMaker endpoints to respond to API requests for applications requiring instant predictions. Batch deployment, process large volumes of data for inference using SageMaker's Batch Transform. Canary or blue/green deployments, gradually shift traffic to a new model version to minimize risk. Create and script infrastructure based on existing architecture and requirements. On-demand versus provisioned resources. On-demand instances, best for applications where demand fluctuates and you want to avoid over-provisioning. Provisioned resources, use when consistent and predictable workloads require always-on resources, such as for large-scale inference jobs. Scaling policies. Auto-scaling policies scale SageMaker endpoints based on real-time traffic using metrics like CPU usage or latency to trigger scaling events. Time-based scaling scale up during expected traffic peaks, for example, marketing campaigns, and scale down during off-peak hours. Infrastructure as code, IAC, options. AWS CloudFormation define the entire AWS infrastructure, SageMaker endpoints, EC2, VPC, as code and automate its deployment and updates. AWS CDK, Cloud Development Kit, write infrastructure code in high-level programming languages, Python, JavaScript, to deploy machine learning infrastructure. Containerization and AWS Container Services. Amazon Elastic Container Registry, ECR, store Docker images of your models for deployment in SageMaker or ECS/EKS. Amazon ECS/EKS, use these for container orchestration, allowing flexible and scalable hosting for machine learning models. Auto-scaling with SageMaker endpoints. Define auto-scaling policies based on metrics like invocation count, number of requests, latency, or CPU utilization. Configure target tracking scaling policies to automatically adjust the number of instances behind the SageMaker endpoint. Applying best practices for maintainable and cost-effective ML solutions. Use spot instances during training to reduce costs. Implement serverless models where real-time responses aren't needed to lower overhead. Automating provisioning with IAC. Use CloudFormation to automate the deployment of SageMaker infrastructure, ensuring consistency and scalability in production. Use AWS CDK to script infrastructure with modern development practices, allowing the reusability of deployment code. Building and maintaining containers. Build Docker images for your models, store them in Amazon ECR, and deploy them on SageMaker or ECS. Use BIOC, bring your own container, when SageMaker's pre-built containers don't meet your needs. Deploying models using the SageMaker SDK. Automate deployment using the SageMaker SDK for Python, allowing seamless integration with training and deployment workflows. Setting metrics for auto-scaling. Track model latency, CPU utilization, or requests per second to scale up or down. Configure alerts using CloudWatch to automatically trigger scaling events. Use automated orchestration tools to set up continuous integration and continuous delivery, C/CD, pipelines. AWS C/CD services. AWS Code Pipeline automates the build, test, and deployment phases for your machine learning workflows. AWS Code Build, used to build Docker containers or run training jobs in a C/CD pipeline. AWS Code Deploy automates deployment to SageMaker, Lambda, or ECS environments. Automation and integration of data ingestion. Automate the ingestion of new datasets into the pipeline using Amazon Event Bridge or AWS Lambda. Integrate these triggers into a C/CD pipeline to start model retraining or inference jobs. Version control systems. Use Git to manage model code, infrastructure scripts, and data versioning for reproducibility. Integrate Git with code pipeline for continuous delivery. C/CD principles in ML workflows. Automate the retraining and deployment of models when new data arrives or model performance declines. Include data validation, model training, testing, and deployment in your pipeline to ensure consistency and reliability. Deployment strategies. Blue/green deployments deploy new versions of the model to a separate environment, green, while keeping the previous version, blue, active. Canary deployments slowly roll out the new model to a small portion of traffic and monitor performance before full rollout. Configuring and troubleshooting C/CD pipelines. Set up code pipeline for model training, testing, and deployment. Configure stages to automate the entire machine learning lifecycle, from data ingestion to model deployment. Integrate code build to build and test models or build Docker containers used for training and inference. Use code deploy to automate the deployment of trained models to SageMaker endpoints, ECS, Lambda, or EKS. Applying continuous deployment flow structures, for example, Git flow, GitHub flow. Set up branching strategies like Git flow or GitHub flow to manage changes in model code, scripts, or data. Ensure that C/CD pipelines trigger based on merges to specific branches, for example, development, staging, production. Automate model deployments when new code is pushed to specific branches. Using AWS services to automate orchestration. Integrate SageMaker pipelines or AWS step functions to automate workflows such as data processing, model training, hyperparameter tuning, and model deployment. Use Event Bridge or Lambda to trigger training or inference pipelines based on events like new data arriving in S3 or specific thresholds being met, for example, model accuracy drops below a target. Configuring training and inference jobs using C/CD pipelines. Set up automatic training jobs in SageMaker pipelines or code pipeline triggered by events such as new data or code changes. Automate the deployment of inference endpoints, updating them when new models are trained and passing model tests. Creating automated tests in C/CD pipelines. Implement tests to validate model performance, including integration tests, testing how the model integrates with applications, and unit tests, testing individual components like data pre-processing steps or specific model functions. Implement end-to-end tests to ensure the entire ML workflow operates correctly before deploying models to production. Building mechanisms to retrain models automatically. Use code pipeline and event bridge to set up automatic model retraining based on conditions such as new data being ingested, model drift detected via SageMaker model monitor, or performance dropping below a set threshold. Summary for Domain 3, Deployment and Orchestration of ML Workflows. Selecting deployment infrastructure. Choose the appropriate deployment strategy, real-time, batch, asynchronous, and provisioning, CPU, GPU, serverless, based on the model requirements, traffic patterns, and cost considerations. Use SageMaker endpoints for real-time inference, batch transform for bulk predictions, and Lambda for serverless, low-latency deployments. Creating and scripting infrastructure. Use AWS CloudFormation or AWS CDK to automate infrastructure provisioning, ensuring consistency and scalability. Implement auto-scaling policies to adjust resources based on demand and optimize cost by using on-demand or provisioned resources. Automating ML workflows with C/CD pipelines. Set up C/CD pipelines using code pipeline, code build, and code deploy to automate the entire machine learning lifecycle. Include automated tests for validating models before deployment, and build mechanisms to trigger retraining based on data drift or model performance degradation. ML solution monitoring, maintenance, and security. Monitor model inference. Drift in ML models. Data drift occurs when the statistical properties of the input data change over time, causing the model's performance to degrade. This can be due to changes in user behavior, external events, or system updates. Concept drift refers to changes in the relationship between the input data and the target variable. The model's learned relationships may no longer hold true as real-world scenarios evolve. Label drift occurs when the distribution of the target labels changes over time. This can happen in classification problems where the proportion of different classes shifts. Techniques to monitor data quality and model performance. SageMaker Model Monitor continuously monitors deployed models for data drift, bias, and anomalies in input/output data. It alerts when the model behavior deviates from expected patterns. CloudWatch Metrics collects custom metrics, for example, inference latency, invocation count, to track the performance and usage of deployed models in real time. Metrics can be set up to trigger alarms for performance degradation. ML Lens design principles for monitoring. Scalability. Monitor models deployed in various environments, from edge devices to the cloud. Latency. Track and optimize the time taken to generate inferences. high latency could indicate performance bottlenecks. Fault tolerance. Ensure that models continue to operate reliably under unexpected conditions. Monitoring tools should detect and alert for system failures or performance drops. Monitoring models in production. SageMaker Model Monitor. Set up model monitoring to track model drift, performance, and data quality. It supports custom monitoring schedules and alerts based on data captured at inference time. CloudWatch alarms. Configure alarms based on metrics like latency, error rates, and invocation counts to automatically trigger alerts if the model underperforms. Monitoring workflows to detect anomalies or errors. Use SageMaker pipelines or AWS step functions to manage the flow of data and monitor for anomalies. Integrate with CloudWatch logs for real-time error detection in your pipeline. Detecting data distribution changes. SageMaker Clarify monitors the output distribution of models to detect bias or significant deviations from the training data distribution. SageMaker Model Monitor. Set up baselines for input data distributions and configure alerts for when deviations exceed thresholds. Monitoring model performance with A/B testing. SageMaker Shadow Testing or A/B testing. Test a new model in a shadow environment or split traffic between two model variants. A/B testing. Compare their performance before fully deploying the new model. Monitor and optimize infrastructure and costs. Key performance metrics for ML infrastructure. Utilization, CPU/GPU usage, memory usage, and disk I/O are key indicators of whether your infrastructure is appropriately sized. Throughput, the number of inferences per second that the model can handle. Availability, ensures that the system is operational with minimal downtime. Measured by metrics like uptime and error rates. Fault tolerance, infrastructure must be able to handle failures and scale appropriately to maintain performance during high-traffic events. Monitoring and observability tools. AWS X-Ray traces requests across your system to identify bottlenecks and performance issues in distributed applications. Useful for debugging issues with SageMaker endpoints, Lambda, and other integrated AWS services. Amazon CloudWatch Lambda Insights provides detailed monitoring for AWS Lambda functions, including memory, CPU usage, and invocation metrics. Amazon CloudWatch Logs Insights allows you to query logs from multiple AWS services, including SageMaker, Lambda, ECS, to troubleshoot issues and understand system behavior. AWS CloudTrail for logging and monitoring retraining activities. CloudTrail records AWS API calls, including those related to SageMaker, enabling you to track model training and deployment events. This is particularly important for auditing and compliance. Instance types and performance. Memory-optimized instances are 5x1e, ideal for tasks requiring large memory footprints, like deep learning models with massive datasets. Compute-optimized instances, C5, P3, best for high-performance compute tasks, such as large-scale model training with GPUs or inference with compute-heavy models. Inference-optimized instances, Inf1, optimized for deep learning inference with specialized chips, for example, Inferentia, for low-cost, high-performance predictions. Cost analysis tools. AWS Cost Explorer, visualize your costs and usage. Track expenses by tags, for example, project, team, or model. AWS Trusted Advisor provides recommendations on cost optimization, including right-sizing your instances and using reserved or spot instances to save money. SageMaker Savings Plans, commitment-based savings plan offering lower prices for long-term SageMaker usage. Configuring and using tools to troubleshoot resources. Use CloudWatch logs to track logs and troubleshoot latency issues, timeouts, or out-of-memory errors. Configure CloudWatch dashboards to visualize key metrics, such as GPU/CPU utilization, latency, and request throughput. Setting up dashboards to monitor performance. Build Amazon QuickSight dashboards to track metrics like inference latency, utilization, and cost across your machine learning workflows. CloudWatch dashboards visualize real-time monitoring data to make informed decisions about scaling and performance tuning. Monitoring infrastructure via Event Bridge. Use Amazon Event Bridge to detect events such as model drift or infrastructure failure. Automatically trigger workflows to retrain models or scale infrastructure in response to predefined events. Right-sizing instance types. SageMaker Inference Recommender recommends instance types for inference workloads based on cost and performance requirements. Use AWS Compute Optimizer to analyze your infrastructure and recommend resizing of EC2 instances or other resources based on actual usage patterns. Troubleshooting capacity and performance issues. Use CloudWatch alarms to set thresholds for scaling up instances when CPU or memory utilization exceeds a defined limit. Resolve latency issues by optimizing instance types, for example, using GPUs for models requiring high compute. Cost optimization. Implement SageMaker savings plans to reduce costs for long-term SageMaker usage. Use spot instances during model training to lower costs. Use instance auto-scaling to reduce the number of instances when traffic is low, saving on compute costs. Secure AWS resources. IAM roles, policies, and groups for access control. IAM roles grant temporary permissions for SageMaker to access AWS services like S3, DynamoDB, and Lambda. Use least privilege roles to limit access only to required services. Bucket policies define access control for Amazon S3 buckets, ensuring that sensitive data such as training datasets is protected. SageMaker Role Manager simplifies the creation of roles with permissions for various SageMaker tasks, for example, training, deployment, monitoring. SageMaker security and compliance features. VPC support deploys SageMaker endpoints inside a virtual private cloud, VPC, for isolated, private access to resources. Ensures the inference environment has no public internet access. Encryption ensure that data at rest in S3, FS, and other storage services is encrypted using AWS Key Management Service, KMS. Encrypt data in transit using SSL/TLS. Data classification and compliance ensure that PII, personally identifiable information, and PHI, protected health information, meet compliance standards like HIPAA, GDPR, or SOC 2. Use Amazon Macie to detect sensitive information in datasets. Controls for network access to ML resources. VPC security groups control inbound and outbound traffic to your SageMaker instances or endpoints. Private link use AWS Private Link to securely connect SageMaker to services like S3, ensuring all traffic stays within the AWS network. Security best practices for C/CD pipelines. Implement role-based access controls in code pipeline to ensure that only authorized users can deploy models. Encrypt the artifacts and logs in code build and code deploy to ensure data security during the build and deployment phases. Configuring least privilege access. Grant only the necessary permissions to users and applications interacting with SageMaker. For example, use fine-grained S3 bucket policies. Enforce least privilege principles by assigning minimum required permissions for each SageMaker operation, training, inference, monitoring. Configuring IAM policies and roles. Create IAM roles for SageMaker to access S3, Lambda, DynamoDB, or other AWS services. Limit the scope of access to only necessary resources. Use AWS Organizations and Service Control Policies, SCPs, to manage permissions at an organizational level. Monitoring and auditing ML systems. Use CloudTrail to monitor and log API calls for SageMaker, ensuring all actions related to model training, deployment, and inference are recorded for auditing. AWS Config ensure that the configuration of your ML resources follows compliance standards and best practices. Building secure VPC networks for ML systems. Create private subnets and use NAT gateways for outbound internet access while securing ML endpoints behind security groups. Use VPC flow logs to monitor network traffic in and out of SageMaker endpoints, identifying unauthorized access attempts. Summary for Domain 4, ML Solution Monitoring, Maintenance, and Security. Monitoring model inference and performance. Use SageMaker Model Monitor and CloudWatch to continuously monitor data drift, model bias, latency, and performance degradation. Implement A/B testing to compare new and old models in real-time environments. Monitoring and optimizing infrastructure and costs. Use tools like CloudWatch, X-Ray, and AWS Cost Explorer to track performance and optimize infrastructure costs. Use SageMaker Inference Recommender and AWS Compute Optimizer to ensure the right instance types are being used for inference. Securing AWS resources. Implement IAM roles, bucket policies, and encryption to secure machine learning artifacts, datasets, and endpoints. Ensure that SageMaker endpoints and data are deployed securely in a VPC, and use encryption both at rest and in transit to protect sensitive data. AWS services and their roles in machine learning. Data ingestion, transformation, and storage services for machine learning. Amazon S3. Amazon S3 is the primary data lake for storing raw, structured, and unstructured datasets used for model training and inference. It's ideal for storing model artifacts, logs, and results after inference. Key features. S3 Select enables querying of specific parts of datasets without downloading the entire file, saving compute and time when preparing data for ML. Object versioning helps track multiple versions of datasets or model artifacts for reproducibility and compliance. S3 Lifecycle Management automatically moves data between storage tiers, optimizing costs based on data access patterns. Use cases, storing training data, archiving model results, and maintaining version-controlled datasets. Amazon Elastic File System, EFS. EFS provides scalable file storage that can be shared across multiple ML training jobs or inference instances, making it useful for distributing data and sharing models. Key features. Multi-as replication ensures high availability for models and datasets during training. Scalability automatically adjusts storage based on workload, useful for training jobs with fluctuating data needs. Use cases, shared storage for model training on multiple EC2 instances or distributed frameworks like TensorFlow with Horovard. Amazon FSx for Lustre. FSx for Lustre is optimized for high-performance computing, providing low latency, high-throughput storage for ML workloads, especially when dealing with large-scale data like high-resolution images or video files. Key features. Integration with S3 moves data between S3 and FSx for Lustre, keeping relevant data in Lustre for fast access while storing the full dataset in S3. Parallel file access supports fast, parallel processing of data, important for training complex models. Use cases, accelerating deep learning models that require large data volumes, such as in computer vision or genomic analysis. AWS Glue. AWS Glue is a fully managed ETL service that automates data preparation for ML workflows, including cleaning, transforming, and cataloging data. Key features. Glue Data Brew provides a no-code interface for cleaning and normalizing data. Glue data quality monitors and ensures data integrity before it's used for model training. Use cases, preparing data for ML, converting raw data into formats ready for training in SageMaker or a feature store. Amazon Kinesis. Kinesis enables real-time data ingestion and processing, crucial for machine learning models that rely on live data for inference, such as fraud detection or recommendation engines. Key features. Kinesis Data Streams captures real-time data, allowing models to process and analyze it instantly. Kinesis Data Firehose transforms and loads real-time data into S3 or Redshift for model training or batch inference. Use cases: ingesting real-time transaction data for live fraud detection models or processing clickstream data for recommendations. Data analytics and querying services for machine learning. Amazon Athena, a serverless query service that analyzes datasets stored in S3 using standard SQL. It's useful for exploratory data analysis (EDA) before building ML models. Key features: SQL queries on S3 data enables quick analysis of large datasets without the need for data movement. Integration with QuickSight allows visualization of insights gained from data exploration. Use cases: performing data quality checks, calculating statistics, or generating features for machine learning models before loading them into SageMaker. Amazon Redshift, a petabyte-scale data warehouse solution that integrates with SageMaker for ML model training and inference directly within Redshift. Key features: Redshift ML lets users build and train models using SQL queries within Redshift, leveraging SageMaker. Columnar storage efficiently stores and retrieves structured data, making it ideal for ML feature generation. Use cases: training predictive models directly on large-scale customer data stored in Redshift, such as churn prediction or sales forecasting. Amazon QuickSight. QuickSight provides data visualization capabilities to help data scientists interpret model outputs, assess feature importance, and monitor model performance. Key features: integration with SageMaker embeds predictions from SageMaker models into dashboards for stakeholders. ML Insights, built-in capabilities for detecting outliers and anomalies in data. Use cases: visualizing model performance and monitoring key metrics, such as model accuracy, precision, or recall. Compute and orchestration services for machine learning. Amazon EC2. EC2 provides customizable compute resources, CPU, GPU, FPGA, for training machine learning models, offering control over the infrastructure. Key features: Spot instances reduces cost by using spare AWS capacity for non-critical training jobs. Elastic GPUs allows scaling of GPU resources for deep learning models. Use cases: running custom ML models on frameworks like TensorFlow or PyTorch, especially for resource-heavy tasks like deep learning. AWS Lambda, a serverless compute service that runs code in response to events, useful for lightweight, on-demand inference tasks or for triggering data transformations. Key features: event-driven ML can trigger SageMaker endpoints for inference when new data is uploaded or streamed. Use cases: real-time ML inference or pre-processing data before sending it to SageMaker for model predictions. AWS Batch. AWS Batch allows you to run batch processing jobs at scale, making it useful for large-scale ML tasks such as batch inference. Key features: dynamic resource allocation automatically provisions compute resources based on job size and number. Use cases: running large-scale inference jobs or distributed training workloads that need to process massive datasets in parallel. AWS Step Functions orchestrates complex ML workflows by chaining together multiple AWS services, creating fully automated ML pipelines. Key features: state management manages the execution of multi-step ML jobs, such as data pre-processing, model training, and deployment. Use cases: automating the ML lifecycle, from data ingestion to model deployment and monitoring. Machine learning-specific AWS services. Amazon SageMaker. SageMaker handles the end-to-end machine learning workflow, from data preparation and training to deployment and monitoring of models. Key features: SageMaker Studio, an IDE for building, training, and deploying models. SageMaker Model Monitor continuously monitors models for data drift and performance degradation. SageMaker Feature Store centralizes feature management for training and inference. Use cases: training, deploying, and managing ML models at scale, including large distributed training jobs and real-time inference endpoints. Amazon Recognition Rekognition uses pre-trained models for image and video analysis, integrating easily into custom ML workflows for tasks like facial recognition and object detection. Key features: pre-trained models, ready-to-use models for computer vision tasks. Sagemaker integration supports custom computer vision models trained in Sagemaker alongside Rekognition. Use cases: facial recognition, object detection, and content moderation. Amazon Comprehend. Comprehend is an NLP service providing sentiment analysis, entity recognition, and topic modeling for unstructured text data. Key features: entity detection and sentiment analysis extracts insights from text data for use in predictive models. Custom models train custom NLP models using Sagemaker. Use cases: analyzing customer reviews, extracting key phrases from documents, and building NLP-based recommendation engines. Monitoring, security, and cost optimization services for ML. Amazon Cloud Watch monitors ML infrastructure and model performance by collecting and visualizing metrics, logs, and events. Key features: CloudWatch alarms automatically triggers actions when performance metrics, for example, latency, memory usage, exceed thresholds. Use cases: monitoring Sagemaker endpoint performance and setting up automated alerts for cost overruns or model failures. AWS Identity and Access Management, IAM. IAM controls access to AWS resources, ensuring that only authorized users can interact with ML models and datasets. Key features: fine-grained permissions, configures role-based access control to limit who can train, deploy, or modify models. Use cases: securing machine learning environments, preventing unauthorized access to model data or endpoints, and ensuring compliance. AWS Auto-Scaling automatically scales ML infrastructure, ensuring optimal performance and cost efficiency during peak and low demand periods. Key features: auto-scaling policies adjust Sagemaker endpoint capacity based on real-time demand, reducing unnecessary cost. Use cases: scaling inference capacity during traffic spikes, ensuring smooth model deployment without manual intervention. Amazon Sagemaker in-depth overview. Amazon Sagemaker is a fully managed service that allows data scientists, developers, and machine learning (ML) engineers to build, train, and deploy ML models quickly. It offers a comprehensive set of tools and integrations to manage the end-to-end machine learning lifecycle, from data preparation and feature engineering to model training, hyperparameter tuning, deployment, and monitoring. Sagemaker is designed to support large-scale ML workflows, providing the necessary infrastructure without requiring extensive infrastructure management. Key components of Sagemaker. 1. Sagemaker Studio. Description: Sagemaker Studio is the integrated development environment, IDE, for machine learning. It provides a single interface where you can build, train, tune, and deploy models. Key features: interactive notebooks, manage and share Jupyter notebooks for data exploration, feature engineering, and model experimentation. Experiment tracking, logs all experiments and trials in one place, tracking changes in code, hyperparameters, and datasets to improve model reproducibility. Automated debugging provides real-time insights and alerts through Sagemaker Debugger to help spot training bottlenecks, overfitting, or underfitting. Model management, built-in tools for monitoring, deployment, and drift detection after deployment. Collaboration supports team-based access to notebooks and experiment results, ideal for distributed machine learning teams. 2. Sagemaker Data Wrangler. Description: a no-code tool for data preparation that simplifies data pre-processing and feature engineering. Key features: data import allows users to import data from multiple sources like Amazon S3, Redshift, Athena, and even Snowflake. Data cleaning and transformation provides over 300 built-in transformations, including handling missing values, one-hot encoding, normalization, and standardization. Data exploration automatically creates visualizations such as histograms, scatter plots, and correlation heat maps to help explore and understand the data. Export pipelines exports the data pipeline to SageMaker pipelines or Python code for seamless integration into model training workflows. 3. SageMaker Autopilot. Description: a fully automated machine learning (AutoML) tool that helps you automatically build, train, and tune models without requiring deep ML knowledge. Key features: automated model selection, runs multiple algorithms and automatically selects the best performing model. Explainability, uses SageMaker Clarify to provide transparency in model predictions, highlighting feature importance and model decisions. Customizable, allows users to modify AutoML pipelines if deeper customization is needed after automated model generation. Performance tracking, provides a leaderboard of all model candidates, showing detailed metrics like accuracy, precision, recall, and F1 scores. 4. SageMaker Pipelines. Description: a service for building and managing machine learning pipelines, helping automate steps such as data preparation, model training, hyperparameter tuning, and model evaluation. Key features: end-to-end automation, automates the entire ML lifecycle, from data ingestion to deployment, ensuring reproducibility. Integration with C/CD tools, seamlessly integrates with AWS Code Pipeline and other C/CD tools to automate retraining and deployment when new data arrives. Reusability, pipelines can be reused across multiple models or projects. Versioning, automatically tracks versions of each pipeline step, so you can easily revert to earlier stages. 5. SageMaker Feature Store. Description: a fully managed repository to store, retrieve, and manage ML features. Key features: centralized feature management, store features that can be reused across different models and pipelines to avoid redundant feature engineering. Real-time and batch ingestion, supports both real-time updates to features and batch ingestion for processing large datasets. Consistency, ensures consistency in feature values between training and inference, reducing data leakage and improving model accuracy. Integrated with other SageMaker services, easily integrates with SageMaker for model training and deployment, allowing for seamless access to the same feature set. 6. SageMaker Experiments. Description: a tool for tracking, organizing, and comparing ML experiments, helping manage large-scale model experimentation. Key features: automatic logging, captures input parameters, code versions, and performance metrics for each training job or pipeline run. Searchable history, makes it easy to retrieve past experiments and compare results across different model configurations. Reproducibility, ensures that model performance can be reproduced by tracking all steps involved in the training process. Integration with Studio, all experiments are logged in SageMaker Studio for easy access and visualization. 7. SageMaker Debugger. Description: a tool that provides insights into the training process by monitoring system and model metrics in real time. Key features: automated anomaly detection, identifies issues like vanishing gradients, overfitting, or underfitting by analyzing metrics such as weights, biases, and activation functions. Real-time training monitoring, continuously tracks model behavior and alerts users of issues during training. Customizable rules, allows the creation of custom monitoring rules to tailor the debugging process for specific models or use cases. Integration with Studio, displays real-time visualizations of training metrics within SageMaker Studio. 8. SageMaker Model Monitor. Description: monitors deployed models in production to detect model drift, bias, and performance degradation. Key features: baseline generation, establishes a baseline during the initial model training, against which future inferences are compared. Automatic drift detection, detects changes in model performance due to data drift, feature drift, or concept drift, triggering retraining if needed. Bias detection monitors for bias in incoming data or model predictions, ensuring compliance with fairness and ethical standards. Alerts and notifications provides automated alerts via Amazon CloudWatch or Amazon SNS when model performance deviates from the baseline. 9. SageMaker Clarify. Description, a service for detecting bias and increasing the transparency of machine learning models. Key features. Pre-training bias detection detects biases in the input dataset before training, such as imbalances in features like gender or race. Post-training bias detection analyzes model predictions for bias and quantifies feature importance to ensure that certain features don't disproportionately affect outcomes. Explainability reports uses Shapley additive explanations to provide explanations for model predictions, helping stakeholders understand how predictions are made. Integrated with pipelines and model monitor, allows for continuous bias detection and explainability during model deployment. 10. SageMaker Automatic Model Tuning, Hyperparameter Tuning Description. SageMaker provides built-in hyperparameter tuning to automatically optimize the hyperparameters of machine learning models. Key features. Automated search uses Bayesian optimization to find the best hyperparameter settings. Multiple tuning strategies, supports grid search, random search, and other customizable search strategies for optimization. Warm start tuning allows users to reuse results from previous tuning jobs to reduce cost and time for subsequent tuning jobs. Integration with SageMaker Studio visualizes the tuning results and hyperparameter impacts on performance directly in the SageMaker Studio interface. SageMaker deployment options. Real-time endpoints. Deploy models to scalable endpoints for low latency inference. Automatically scale based on incoming traffic. Supports multi-model endpoints to reduce deployment costs by hosting multiple models on a single endpoint. Batch transform. Ideal for running inference on large datasets when real-time responses aren't needed. Can process millions of data records in parallel using powerful EC2 instances. Asynchronous inference. Designed for long-running, complex inferences where immediate responses aren't required. Sends notifications via Amazon SNS or other services when inference is complete. Serverless inference. Automatically provisions the infrastructure needed for inference and scales down when not in use, minimizing idle costs. Ideal for applications with unpredictable traffic patterns. Edge inference, SageMaker Neo. Optimizes models for deployment on edge devices by compiling them to run with high efficiency on hardware like NVIDIA, Intel, and ARM processors. Security and compliance in SageMaker. VPC integration. All SageMaker endpoints and training jobs can be configured within a virtual private cloud, VPC, to ensure network isolation. Private link enables secure and private communication between SageMaker and other AWS services without traversing the public internet. IAM roles. Uses fine-grained identity and access management, IAM, policies to control access to models, datasets, and SageMaker resources. Supports role-based access control for data scientists, engineers, and other team members. Data encryption. Supports encryption at rest using AWS Key Management Service, KMS, for datasets, model artifacts, and logs. End-to-end encryption. Amazon Bedrock, in-depth overview. Amazon Bedrock is a fully managed service that provides access to a suite of foundation models, FMs, from leading AI and ML providers like Amazon, Anthropic, Stability AI, and AI21 Labs. Bedrock allows developers and data scientists to build and scale generative AI applications without managing the underlying infrastructure. It simplifies the process of leveraging large, pre-trained models for various tasks such as text generation, image generation, and multimodal AI. Amazon Bedrock simplifies access to state-of-the-art foundation models and generative AI, making it easy for businesses to build and scale machine learning applications without the need for managing underlying infrastructure. It supports a variety of use cases, from text generation to sentiment analysis, while ensuring data privacy, security, and integration with the broader AWS ecosystem. Key concepts in Amazon Bedrock. Foundation models, FMs. Bedrock provides access to multiple foundation models, which are large pre-trained models that can be customized for specific tasks. These models are pre-trained on vast amounts of data and can be fine-tuned using specific datasets to adapt them to a variety of use cases. Generative AI. Bedrock specializes in generative AI, which involves models that generate content such as text, images, or even code. This includes tasks like summarization, question answering, content generation, and text-to-image tasks. The service provides multiple foundation models optimized for different types of generative tasks. For example, GPT for text generation, Stability Diffusion for image generation. Fully managed. Bedrock handles all infrastructure management, allowing data scientists and developers to focus on building and deploying applications without worrying about provisioning resources, scaling, or maintenance. Foundation models available in Bedrock. Amazon Titan. Text model supports general-purpose text generation, language understanding, and text completion tasks. Amazon Titan models can be fine-tuned with specific datasets for specialized use cases such as customer support automation, summarization, or content generation. Embeddings model produces vector embeddings for text inputs, useful for similarity search, clustering, and semantic search tasks. This is ideal for building retrieval augmented generation (RAG) systems where relevant documents are fetched based on a query. Anthropic Claude. A conversational AI model built for safe and reliable interactions. Claude can be used for tasks like customer service chatbots, virtual assistants, and other conversational interfaces that require a deep understanding of context and human language. AO21 Labs Jurassic 2. Text generation. Jurassic 2 is a robust model for natural language understanding and text generation, useful in tasks such as chatbots, creative writing, or business intelligence reporting. This model excels at generating human-like text and understanding complex prompts, making it highly useful for use cases like text summarization, translation, or creating marketing content. Stability AI Stable Diffusion. Image generation. This model is designed for text-to-image generation. It can be used to generate high-quality, realistic images based on textual descriptions. Useful for creative applications like generating marketing visuals, product designs, or artistic creations from natural language inputs. Key features of Amazon Bedrock. Customization with fine-tuning. Bedrock allows users to fine-tune foundation models with their own datasets. This is especially useful for adapting a general-purpose model to a specific task or industry, such as customizing a model for medical diagnosis, customer service, or industry-specific sentiment analysis. Fine-tuning helps to optimize performance and ensure that the model delivers more accurate results for your specific use cases while preserving data security and privacy. Multi-model access. Bedrock allows users to access a variety of foundation models from different providers in one platform. This flexibility enables users to select the best model suited for their use case, whether it's text generation, image generation, or multimodal tasks. Users can experiment with different models to find the optimal one for their specific needs, without needing to manage multiple model deployments across platforms. Scalable infrastructure. As a fully managed service, Bedrock handles all infrastructure scaling automatically. This is particularly useful for applications that have unpredictable workloads or require low-latency responses, such as real-time chatbot services or large-scale image generation tasks. Bedrock's infrastructure ensures that applications using foundation models are scalable and can handle spikes in demand without requiring manual intervention or additional provisioning. Secure fine-tuning. Bedrock ensures the privacy and security of data during fine-tuning. Users can fine-tune models with their data without exposing the information externally. This is critical for industries like healthcare, finance, or legal services, where data privacy is paramount. No proprietary data is shared with the model provider during the fine-tuning process, ensuring compliance with industry-specific regulations and data protection laws. Easy integration. Bedrock is integrated with other AWS services like Amazon Sagemaker, AWS Lambda, and Amazon API Gateway. This makes it easy to embed foundation models into broader ML workflows and production applications. Bedrock also supports integration with Amazon Comprehend for text analysis or Amazon Recognition for image analysis to create more comprehensive AI-driven applications. Use cases for Amazon Bedrock. Text generation. Bedrock can be used to generate human-like text responses, making it ideal for creating customer service chatbots, content creation tools, automated reports, and product descriptions. Fine-tuning a model on specific company or industry data allows for more personalized and context-aware responses in customer interactions. Content moderation. Bedrock's models can automatically analyze text or images to detect inappropriate content, providing an efficient way to moderate user-generated content in online platforms. Customizing models with specific moderation rules allows companies to tailor moderation standards to their needs. Sentiment analysis. Bedrock supports models that can perform sentiment analysis on customer reviews, social media posts, or support tickets. This helps companies better understand customer feedback and adjust their products or services accordingly. Using Amazon Titan or Claude models, users can fine-tune sentiment analysis models to focus on specific product categories or business areas. Text-to-image generation. Stable diffusion models from Stability AI, accessible via Bedrock, allow businesses to generate marketing images, design concepts, or even personalized artwork based on text descriptions. For industries like e-commerce, fashion, and advertising, these models can generate product images or visuals from customer descriptions or design briefs. Summarization and translation. Jurassic 2 and Titan models can summarize large documents, emails, or reports into concise, readable outputs. This is useful in scenarios like legal or financial reporting, where processing large volumes of text is required. These models can also be used to translate content between languages, helping global businesses engage with non-native speakers more effectively. Conversational AI. Claude models by Anthropic excel at building safe, reliable conversational agents for customer service or virtual assistants. This can be used in industries such as retail, hospitality, and healthcare to offer 24/7 assistance to customers or patients. Fine-tuning conversational models allows businesses to create personalized virtual assistants with deep industry knowledge and specific customer support capabilities. Security and compliance in Amazon Bedrock. Data privacy. Bedrock ensures that data used during fine-tuning remains secure and private. Customer data is not shared with the model providers, and Bedrock supports encryption at rest and in transit to meet industry compliance standards. Users can fine-tune foundation models without compromising proprietary or sensitive information. AWS Identity and Access Management, IAM. Bedrock is integrated with AWS IAM, allowing organizations to set up fine-grained access controls to manage who can access and modify models. Role-based access ensures that only authorized personnel have access to key functions, such as fine-tuning or deploying models. End-to-end encryption. All interactions with Bedrock are encrypted using AWS Key Management Service, KMS. This ensures the highest level of security for data during model fine-tuning, inference, and data storage. Bedrock is compliant with a wide range of security and data protection regulations, making it suitable for use in industries like healthcare and finance. Integration with other AWS services. Amazon Sagemaker. Bedrock integrates seamlessly with Sagemaker for custom model training, deployment, and monitoring. Users can build custom workflows where Bedrock models serve as the backbone for generative tasks and SageMaker handles broader model management and orchestration tasks. Amazon Comprehend. Bedrock's language models can complement Amazon Comprehend by generating responses based on insights extracted from text data. For example, Comprehend can identify key entities and Bedrock can be used to generate customer responses or marketing copy based on those insights. Amazon S3. Amazon S3 can be used to store fine-tuning datasets, model artifacts, and inference results from Bedrock models, providing a scalable storage solution integrated with Bedrock's foundation models. Amazon API Gateway and AWS Lambda. API Gateway and Lambda can be used to expose Bedrock-powered models as APIs. This allows for building serverless applications that leverage Bedrock for real-time inference and content generation. Trade-offs between AWS storage solutions, S3, AFS, FSx, for ML workflows. Amazon S3, simple storage service strengths. Cost-effective, S3 is ideal for storing large amounts of unstructured or structured data with its pay-as-you-go pricing. Durable and scalable, S3 automatically scales to accommodate any volume of data and replicates data across multiple availability zones, as is, ensuring 99.999999999% durability. S3 intelligent tiering automatically moves infrequently accessed data to cheaper storage classes, minimizing costs. Integration works well with AWS services like SageMaker, AWS Glue, and Kinesis for data ingestion, preparation, and model training. Use cases. Ideal for storing raw training datasets. Great for storing model artifacts after training. Storing logs and output of batch inference jobs. Trade-offs. No file system access, S3 is object storage, so it doesn't have traditional file system capabilities. You can't mount it like you would a file system, though it works with Cephs for some file access. Latency, higher latency compared to EFS or FSx when accessing large datasets frequently. Amazon EFS, elastic file system strengths. File system semantics, fully managed network file system, NFS, that can be mounted to multiple EC2 instances or SageMaker notebooks, making it perfect for scenarios requiring shared storage across multiple compute nodes. Elasticity automatically scales up or down based on data consumption without the need to provision or manage capacity. Throughput can handle high-throughput workloads, useful when training ML models that need fast access to data across instances. Use cases. Ideal for storing intermediate datasets during data pre-processing or feature engineering. Best for team-based collaboration where multiple ML developers need access to the same datasets. Trade-offs. Higher cost compared to S3 for storing large amounts of data, especially if the data is not accessed frequently. Not suitable for batch-oriented workloads where data is written once and accessed infrequently, as S3 is more cost-effective in those cases. Amazon FSx for luster strengths. High throughput, designed for high-performance computing, HPC, and large-scale data processing, offering sub-millisecond latencies. Integration with S3, FSx for Luster can import and export data from S3, allowing for seamless use in workflows where high-speed file system access is needed for training, and S3 is used for longer-term storage. File system optimized for HPC, FSx is great for scenarios where fast read/write access is required, especially with ML models trained on large datasets, for example, images, videos, or genomics data. Use cases. Perfect for large-scale model training and distributed training workflows where data needs to be processed in parallel across multiple GPUs or instances. Suitable for temporary high-speed storage during model training or batch inference tasks. Trade-offs. Higher cost, it is more expensive than both S3 and EFS and is only ideal for specific high-performance workloads. Temporary storage, FSx is best for short-term storage needs, as data is generally transferred to S3 for long-term retention to reduce costs. Data streams, Kinesis, Apache Kafka, and Flink in ML data pipelines. Amazon Kinesis. Kinesis data streams. Real-time ingestion streams massive volumes of data in real time for ML applications. Data pipelines. Kinesis is often used for streaming event data, for example, clickstreams, IoT data, into machine learning models for real-time predictions, anomaly detection, or fraud detection. Integration with SageMaker, it can stream data directly into SageMaker endpoints for real-time inference or into SageMaker Data Wrangler for processing and feature engineering. Example, streaming financial transactions to detect fraud in real time using a SageMaker deployed model. Transactions flow through Kinesis data streams and trigger Lambda functions or SageMaker endpoints for instant fraud detection. Trade-offs. Requires careful planning for stream partitioning and shard scaling to avoid bottlenecks during ingestion. Apache Kafka. Use case in ML pipelines. Open source distributed streaming, Kafka is used for event streaming and is often deployed in ML pipelines where multiple microservices and applications need to exchange data in real time. Data lakes. Kafka can stream data from various sources into a data lake, for example, S3, for further processing and ML training. Example, in a retail platform, customer interactions are streamed via Kafka, processed in AWS Lambda, and the data is ingested into SageMaker for personalized product recommendations. Trade-offs. Requires more operational overhead compared to Kinesis as it's a self-managed service unless using managed services like MSK, managed streaming for Kafka. Amazon Managed Service for Apache Flink. Role in ML. Flink enables real-time processing of streaming data and can run complex stream processing applications. ML pipelines. Flink can be used to pre-process data on the fly, perform real-time feature extraction, and pass the processed data directly to SageMaker or other AWS services for real-time inference. Example, in predictive maintenance, Flink processes IoT sensor data in real time, applies transformations like smoothing or scaling, and then streams the processed data to a SageMaker endpoint for fault detection predictions. Trade-offs. More complexity compared to Kinesis for setting up stateful processing applications. Practical scenarios, using AWS Glue and SageMaker Data Wrangler for feature engineering. AWS Glue. ETL, extract, transform, load. AWS Glue automates the extraction, transformation, and loading of data from various sources, S3, RDS, Redshift, into a data format suitable for machine learning. Data Catalog creates and manages metadata, making datasets more discoverable across your organization. Example, in a customer churn analysis use case, Glue extracts customer interaction data from various databases, normalizes and cleanses the data, and transforms it into an optimized format, Parquet, stored in S3 for feature engineering. Use with SageMaker, Glue transforms raw datasets and feeds them into SageMaker for model training or SageMaker Feature Store for feature sharing across models. SageMaker Data Wrangler. Low-code/low-code, Data Wrangler simplifies data preparation with its visual interface, making it easy for data scientists to clean, transform, and perform feature engineering on datasets. Example, in fraud detection, you might use Data Wrangler to remove outliers from transaction datasets, apply one-hot encoding to categorical features, for example, transaction types, and normalize continuous features, for example, transaction amount, before feeding them into a fraud detection model. Pipeline integration. Data Wrangler workflows can be exported as SageMaker pipelines for automated data transformations in production. Advanced techniques, tokenization, data augmentation, encoding methods. Tokenization, NLP. What it is. Tokenization involves splitting text into smaller units, tokens, such as words or subwords, which are then used as inputs to NLP models like BERT or GPT. Types. Word-level tokenization splits sentences into individual words. Used in basic NLP tasks like sentiment analysis or classification. Subword tokenization, byte pair encoding, word piece, breaks down rare words into more frequent subwords, allowing the model to understand context better for low-frequency words. Example, in a chatbot system, tokenization is applied to incoming customer queries, which are then passed into a pre-trained language model like GPT-3 for generating responses. Data augmentation. Image is what it is. Data augmentation involves creating additional training data by applying transformations like rotation, flipping, or cropping to images. Use case. In medical imaging, augmenting a small dataset by rotating and flipping X-ray images helps improve the model's ability to detect anomalies from different angles. Advanced encoding techniques. One-hot encoding converts categorical variables into binary vectors. Useful for features like user gender or transaction type in fraud detection models. Label encoding assigns unique integer values to categories, often used when there is an ordinal relationship between categories. Embeddings, low-dimensional dense vectors representing categorical features, useful for NLP tasks where high-dimensional one-hot encodings are inefficient. Compliance regulations, GDPR, HIPAA, and ML data. GDPR, General Data Protection Regulation implications for ML, requires that any personally identifiable information, PII, be processed in compliance with strict data privacy and security regulations. Anonymization and encryption, use SageMaker and S3's encryption features to ensure PII data is encrypted at rest and in transit. Right to be forgotten, any ML system handling customer data must ensure the ability to delete data upon user request, including removing that data from training datasets or models. HIPAA, Health Insurance Portability and Accountability Act implications for ML. Any system handling protected health information, PHI, must comply with strict security controls. Use cases. In healthcare ML applications, encrypting PHI data in SageMaker and using AWS HealthLake for managing sensitive health records is crucial. Auditability. AWS Cloud Trail helps log access to PHI data for compliance audits. Bias detection in ML tasks, NLP, image data NLP tasks. Problem. Bias in training data can cause NLP models to generate biased or inappropriate outputs. Detection and mitigation. Use SageMaker Clarify to measure bias metrics such as class imbalance and disproportionate outcomes across demographic groups. Example, in a customer support chatbot, Clarify can highlight if certain demographic groups receive disproportionately fewer positive responses. Image data. Problem. Bias in image datasets. For example, underrepresentation of certain demographics can lead to biased model outputs. Mitigation. Augment the dataset to balance class representation or use synthetic data generation to mitigate bias. Algorithm trade-offs, XGBoost versus random forest. XGBoost. Strengths, efficient and scalable, often outperforming traditional algorithms. Handles missing data well and supports early stopping for faster training. Use case, ideal for structured/tabular data, such as in fraud detection or customer churn prediction. Trade-offs, computationally intensive, can be prone to overfitting without careful tuning of hyperparameters. Random forest. Strengths, less prone to overfitting due to averaging multiple decision trees. Easier to tune than XGBoost. Use case, works well in situations with limited hyperparameter tuning requirements, such as simple binary classification tasks. Trade-offs, can be slower for larger datasets and less performant than XGBoost for more complex problems. Distributed training in SageMaker. Data parallelism, splits the dataset across multiple GPUs or instances. Each worker trains on a different slice of data but uses the same model. Model parallelism splits the model across multiple GPUs, useful for very large models that don't fit into the memory of a single GPU. Use case, data parallelism is common in large-scale image recognition or NLP tasks, while model parallelism is used in large transformer-based models like GPT or BERT. Hyperparameter tuning, grid search, random search, Bayesian optimization. Grid search. Description exhaustively tries all combinations of hyperparameters. Trade-offs, computationally expensive but guarantees finding the best combination. Use case, small datasets or models where the number of hyperparameters is limited. Random search. Description randomly selects hyperparameter values to try. Trade-offs, more efficient than grid search but does not guarantee finding the best values. Use case, large models or datasets where trying all combinations is not feasible. Bayesian optimization. Description uses a probabilistic model to choose the next set of hyperparameters based on previous trials. Trade-offs balances exploration and exploitation, often finding good hyperparameters faster. Use case, ideal for large-scale ML tasks or deep learning models where fine-tuning hyperparameters is critical for performance. Model drift and monitoring with SageMaker Model Monitor. Types of drift. Data drift occurs when the input data changes over time. Concept drift occurs when the underlying relationship between input features and the target variable changes. Example, in a fraud detection model, if new fraud schemes emerge that are different from the training data, concept drift can occur. SageMaker Model Monitor monitors model predictions in real time to detect drift. Triggers alerts if drift is detected, allowing for retraining or updating the model as needed. A/B testing for model comparison. What it is, deploys 2 or more model versions in parallel and compares their performance. Use case, in a recommendation system, A/B testing can be used to see if a new model generates higher click-through rates compared to the old model. Shadow testing, a variant of A/B testing where the new model runs in parallel with the old model but doesn't affect production outcomes until proven better. Cost tracking with AWS Cost Explorer. Resource tagging, use tags to group ML workloads by project or department, allowing for granular cost tracking. Cost Explorer dashboards provides visual breakdowns of costs by tags, instance types, or services, helping optimize resource usage. Use case, tagging training and inference jobs in SageMaker to track the cost of specific models or projects. Security enhancements, IAM policies, VPC configurations, and best practices for securing ML workflows. IAM policies. Fine-grained access, create least privilege policies for SageMaker resources. For example, allow only certain users to access the model registry while restricting access to production endpoints. Best practices, use roles instead of long-term credentials for SageMaker notebook instances and training jobs to interact with S3 or other services. VPC configurations. VPC endpoints, use VPC endpoints to securely connect SageMaker resources to S3 or other services without using the public internet. Network isolation, use SageMaker network isolation to block access to the internet during model training, ensuring sensitive data remains secure. Private link. Usage, use private link to securely connect services across VPCs or from on-premises environments to AWS without exposing traffic to the internet.